Hi students, welcome to this video session. I remain Samuel Chukwu Emeka as usual. In this video session, we shall continue our study of probability. We shall discuss your Module 6 homework. And your Module 6 homework covers probability. It covers permutations, combinations, and the fundamental counting principle. So the notes are here, but the video will be posted here. Module homework and exam study guide. So we shall discuss your Module 6 homework, and this is a study guide. We shall compute the probabilities of events. We shall compute the conditional probabilities of events. We shall apply the fundamental counting principle. We also call it some textbooks call it the counting principle. We shall also determine the number of permutations of items. We shall determine the number of permutations of total items, taking some items at a time. And we shall determine the number of combinations of total items, taking some items at a time. Please, this is very important, the prerequisites. You have to view the Module 5 homework study guide. It is very important that you do so. It is very important that you view all the videos in the playlist under probability, and also all the videos in the playlist on combinatorics. Combinatorics include the fundamental counting principle, permutation, Part 1, combination, Part 1, permutations and combinations, Part 1, Part 2, Part 3. It is highly recommended that you view these videos so that you would gain a good understanding of this homework. Question 1. E and F are two events. The probability of event E and event F is equal to 0.4. Probability of event E is 0.5. Find the probability of event F given event E. Okay, that is event F given event E. So this is the formula. It has a formula, and this is the formula. Probability of event F given event E is equal to the probability of the events E and events F, probability of events E and F, divided by the probability of event E. So that gives us 0.4 divided by 0.5, and that is 0.8. You can also, the formula can also be written as the cardinality of E and F divided by cardinality of E. So you can also have the formula this way: 430 divided by 830, and that gives you 0.518. Question 3. A single card is selected from a standard 52 card deck. What is the probability that the card drawn is a king? In a standard card, in a standard 52 card deck, we have 4 kings. So the probability will be 4 out of 52, which is 1 out of 13. Question 4. A single card is selected from a standard 52 card deck, but it is told that the card is cut. When we talk about cut, we mean Jack, Queen, or King. What is the probability that the card drawn is a king? We can reward this as what is the probability that the card drawn is a king, given that this card is cut. So first of all, let's find how many cards we have in a standard 52 card deck. And when we talk about card, we mean jack, queen, or king. So in a standard 52 card deck, we have 4 kings, we have 4 jacks, we have 4 queens. So the cardinality of card that we have is 4 plus 4 plus 4, which is 12. So the probability of drawing a king, given that it is a card, okay, the probability of drawing a king, given that it is a card, is the cardinality of king over cardinality of card. And that is 4 out of 12, which is 1 over 3. Question 5 deals with factorials. When we talk about 6 factorial, we mean 6 times 5 times 4 times 3 times 2 times 1. You can do this with your calculator, the calculator on your computer. I'm gonna pull it up. If you're using Windows 8, you just point at the topmost right, and then you click on the first icon, the search icon, and you just type in calculator. And of course, this is the first one. Usually you have it like this. Usually in standard, you click view and you click scientific, and the factorial is just here, n factorial. So all you need to do, you do 6 and you do factorial. It gives you 720. You want to do 10, you just do 10 and you do factorial. So you have this, it's an exclamation mark on your computer, on your scientific computer. You have it. Next one, question 10. How many different simple random samples of size 5 can be obtained from a population whose size is 49? If you view the prerequisite videos, you will understand how I did this. Of course, this means it is a case of combination, because the order does not matter at all. And when you want to do 49 comp 5, or you say comp 5 from 49, or you say 49 comp 5, or you say 49 combination 5, you have this formula. So it will be, if you come and write 49 times 48 times 47 times 46 times 45 times 44, that is a Herculean task to do. Okay, and if you come to use your calculator, you come and do 49 factorial, it is too much. You're not gonna write all these. It's too much. You can come and start doing 49 factorial, then divided by then you find maybe you find 44 factorial, and then you multiply, you save it in memory, m plus, and then you find 5 factorial, and you multiply it by recall memory equal to this. You change the memory, you put in a new memory, and you now do 49 factorial divided by recall memory, and that gives you 1906. Okay, well, you could do this anyway, but assuming you were not using calculator, okay, or assuming you were not using calculator, you could still simplify it. And I explained this in the prerequisite videos, how you do it. So please view the prerequisite videos to know how you can simplify it. Question 11. In a survey of 400 randomly selected people, it was determined that 24 play soccer. What is the probability that a randomly selected person plays soccer? So this is the definition of probability. The sample space is 400. The event space is 24. So the probability of selecting someone that plays soccer would be the cardinality of the event divided by the cardinality of the sample space. You have 24 divided by 400, and that gives you 0.06. Question 12. Mark is preparing for his GRE exam. During testing, he will be allowed to select 3 schools to which his scores will be sent at no cost. If there are 10 colleges he is considering, how many different ways could he fill out the score report form? So this is also a case of combination. I explained it in the prerequisite video because order does not matter. So this is like saying 10 combination 3, or you say com 3 from 10, or you say 10 com 3, and that is the formula. Okay. Let me explain this again from here. If you don't want to do it this formula, you can still use this calculator to do it. I will do it step by step this time around. So what you can do is this. MC is change the memory. So once you press it, it removes the memory. This is 10 factorial divided by 7 factorial times 3 factorial. So what you might want to do, you start from the denominator. You first of all do 7 factorial. It gives you this. Then save this in memory. Just press M+ to save it in memory. Then you do 3 factorial. It gives you this 6. Then do times recall memory. It gives you this 30240. So this is not a long number. If you want, you can write it down in your notebook, or you can put this as the new memory. For us to put this as the new memory, I will have to change memory, and then I will put memory again to put this as the new memory. Then this is the denominator right here. The denominator will give us 30240. Now I come to the numerator. I press 10 factorial. It gives me this. Divided by recall memory. Memory recall. And this will be equal to 120. So 120 ways he can. There are 120 different ways he can fill out the score report form. Okay, I simplified this. If you look at how I did it, I simplified it. You will need to watch the prerequisite video, please. You will need to. Question 13. List all the combinations of 4 items A, B, C, and D, taking 2 at a time. Verify your answer. So this is like saying 4 combination 2. But let us list it first. In combination, order does not matter. AB is the same as BA. AC is the same as CA. AD is the same as DA. BC is the same as CB. BD is the same as DB. CD is the same as DC. In combination. So when we are listing it, this is just AB, AC, AD, BC, BD, CD. Gives us 6 combinations. How do we verify it? Just do 4 combination 2. When you do 4 com 2, or you say com 2 from 4, okay, or 4 combination 2, you use the formula, you still get 6 combinations. So that is how you verify it. Question 14. List all the permutations of 4 items A, B, C, D, taking 2 at a time. Verify your answer. In a permutation, order does matter. That is one of the differences between permutation and combination. In permutation, order matters. The order of arrangement matters. In combination, the order of arrangement does not matter. So in a permutation, AB is not the same as BA, but in a combination, it is the same. But in a permutation, it is not the same. So we have AB, AC, AD, then BC, BD, then we have CD. Then we turn again, in fact, the simplest way to list it is when you do AB, write BA, AC, write CA, AD, DA, BC, CB, BD, DB, CD, DC. Okay? This is not Washington, D.C., okay? Okay. So how many you got, folks? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 permutations. And how do you verify it? Just do 4 palm 2. 4 permutation 2, or you say 4 palm 2, or you say palm 2 from 4. Some of you that do gambling, you should know what I'm talking about. Palm 2 from 4. So you use the formula, you will get 12 permutations. Folks, what do you notice here? And I said this in the prerequisite video. If you see that 4 come 2 times 2 factorial will give you 4 palm 2. Okay, 6 times 2 factorial will give you 12. Question 15. A recent SAMDOM survey found that 8.6% of high school dropouts are 16 to 17-year-olds. In addition, 5.5% of high school dropouts are white, 16 to 17-year-olds. What is the probability that a randomly selected dropout is white, given that he or she is 16 to 17 years old? Round to 4 decimal places as needed. I have explained before as needed. So we can say let dropout be D and let white be W. What is the probability of selecting a white given that he is a dropout? Okay. What is the probability of selecting a white given that he is a dropout 16 to 17 years old? Selected dropout is white given that he is 16 to 17 years old. So you use the formula, probability of white and being dropout is 5.5% divided by probability of being dropout 8.6%, and that gives you that 0.6395. You can verify it with the calculator. 0.055 divided by 0.086. So 6395. Question 16. Samuel received a shipment of 8 laptops from Best Buy. 3 of the laptops are defective. If 2 laptops are randomly selected, A, what is the probability that both laptops work? B, what is the probability that at least one of the 2 laptops does not work? Let's define the terms first so that it will be easier for us. Let the defective laptops be D and let the working laptops be W. The cardinality of the sample space is 8 laptops. Defective ones is 3. Working laptops is, of course, it will be 5. So what is the probability of selecting a defective laptop? 3 out of 8. What is the probability of selecting a working laptop? 5 out of 8. In this case, we are looking at this as what we call dependent events, which means it's without replacement. Without replacement. So what is the probability that both laptops work? You're selecting 2 laptops randomly. What is the probability that both laptops work? So it could be that, the first one works will be 5 out of 8 times the second one works. Now look at this. Now it's 5 working laptops, so probability of selecting the first one that work will be 5 out of 8. Then times, when you have selected one that works, you are not replacing it. You did not replace it. That is why it's a dependent event. Remember, dependent events are, we talked about this in Module 5. Two events are said to be dependent if the probability of one event occurring depends or is affected by the probability of the occurrence of the previous event. So when you have selected one laptop that works, the probability is 5 out of 8. Then you didn't replace it. You kept it. So if you didn't replace it, you're short of 1. NS is short of 1, and NW, the number of working ones, is short of 1. So these are working laptops. You didn't replace it, so it becomes 7. You didn't replace this one, of course, that's 4. How many are now in the box? 4 working ones out of a 7. So what is the probability that you will pick the second one? That will now be 5 over 8 times 4 over 7. And that will give you 0.357. You are asked to round answers to 3 decimal places as needed. Does that make sense? This is dependent events without replacement condition. B, what is the probability that at least one of the 2 laptops does not work? We have 2 methods to solve this. I will give you my method, and I will give you the method that your textbook uses. Both methods work. You just choose which one you prefer. I will start with my method since I'm the teacher, of course. Okay, so listen, if you want at least one, and we talked about this, I talked about it in the video on probability. I talked about it in a Module 5 homework. At least 1 means greater than or equal to 1. At least. So that at least one of the 2 laptops does not work. It could mean that the first one does not work, and the second one does. So this is, you see, multiplication rule. You also see addition rule, or. Remember the and or. Or it could be that the first one does work and the second one does not work. Or it could be that both of them does not work, because it could be 1 or more than 1, because you are selecting 2 laptops randomly. So at least 1 means 1 or the 2. Okay, it means greater than or equal to 1. So I explained it here also. Okay, and they didn't tell us in what order, so this means in any order. They didn't specify the order. So first one does not work and the second one does work, or first one works and the second one does not work, or just both of them do not work. So that the first one works is 3 out of 8. You did not replace it. This is still without replacement. That the second one, first one does not work is 3 out of 8. You did not replace it. Second one works will be 5 out of 7, because you still have 5 working ones, but you are now short of 1 since you did not replace one of these. Okay, so that probability of selecting a second one that does work will be 5 out of 7. Or is the plus. First one works. You have 5 out of 8 because 5 works. So probability of selecting the first one that works is 5 out of 8. You did not replace it, so you're short of 1, which means 7. But you still have 3 defective ones that does not work. So the probability that the second one does not work will be 3 out of 7. Are you taking note of this? Take note of it. Or is the plus. The probability that the first one does not work is 3 out of 8. And times the probability that the second one does not work, okay, will now be 2 out of 7. So when you do the computation, you get 0.643. Do you like this? If you don't like this method, that's fine. You can use the method in your book, that probability that at least one does not work is 1 minus probability that both works. So I know some of you will say that this method is simpler, right? Yeah. Well, any way you understand it, provided you get it right, provided you get the concept right, my work is to show you different ways to solve a problem. I do that for all my students because some students don't learn one way. And mathematics is, I thank God I have the talent that I can explain any difficult math concept. No matter how difficult it is, I can break it down to simple terms. And I can use several ways to explain it to you. Even if you don't understand any of these two ways, I can still find a way to explain it to you. Yeah, but this second way you can use it also. Probability that at least one does not work will be 1 minus probability that both works. So 1 minus 0.357. You still get the same answer. Okay. Question 17. Outside a home, there is a 4-key keypad that can be used to open the garage if the correct 7-digit code is entered. A. How many codes are possible? B. What is the probability of entering the correct code on the first try, assuming that the owner does not remember the code? So we did this. If you view the video on a fundamental counting principle, you will understand it more. The way I solved it with a multiple choice question. How many options do you have per question? So view the video on fundamental counting principle. But you could, you could do a 4 exponent 7 to give you 16,384 ways. And then the probability, you only have one correct code out of all these possible codes. You only have one correct code. So the probability will be 1 out of 16,384. That will be the probability. Question 18. A bag of 34 marbles contains 14 red marbles, 12 yellow marbles, and 8 purple marbles. A. What is the probability that 2 randomly selected marbles are both red? This is still without replacement. Okay. And some of you might ask me, okay, Mr. C, how do you know which one is without replacement and which one is replacement? They will tell you in the question. If it's going to be with replacement, they are going to tell you. If they say it's replaced, they will tell you. They will let you know. In those cases, it will be independent events. Yeah, but if they just ask a question like this, whereby they did not tell you that it is replaced, then automatically you should know that it is without replacement. You're selecting two marbles at random. When you select 2 marbles at random, you did not. You probably selected the 2 at a time, or you selected 1 at a time. You didn't replace it. You select 2 marbles at random from a bag of 34 marbles. The remaining there will be 32. Yeah, but we are taking it that you selected it 1 at a time, and you did not replace the first one you selected. That is the way we say it, as being without replacement, which means it's dependent event. So you have 2 events. You select the first one, you didn't replace it. So because you did not replace it, the sample space is now short of 1. The original sample space is now short of 1. So the probability of picking any other thing in the second event will be affected because the sample space is now short of 1. Okay. B. What is the probability that the first marble selected is red and the second yellow? So this is what we call in order. In order. They told us in this one that it is in order. First is red, second is yellow. C. What is the probability that the first is yellow and the second red? This is still in order. D. what is the probability that one marble is red and the other yellow? So in this case, it is without order. Okay, so they just said one marble is red and the other yellow. So which means the first marble could be red and the second could be yellow. Or, you see the or comes addition event. You see, when you say the first marble is red and the second yellow, and the and is multiplication rule. Or you say or addition rule. The first marble is yellow and the second marble is red. And you see, so you have and you have or and you have and. Okay, so you have a multiplication rule, then you have the or, which is plus, and then you have the and again, which is multiplication rule. All right, so the first thing you do is to define it. Let red be uppercase R, yellow be Y, purple be P. Of course, the cardinality of the sample space is 34. You can verify that by adding 14 plus 12 plus 8. 14 plus 12 is 26. 26 plus 8 will give you 34. The cardinality of R is 14. Cardinality of yellow is 12. Cardinality of P is 8. So this is without replacement. Dependent events. Both are red. So you did not replace it. So probability that the first one is red is 14 out of 34 times you didn't replace it. So the sample space is short of 1, and also the red is short of 1. So it will be 13 out of 33. Okay? 13 out of 33. So when you do that, you have this. Does that make sense so far? Does that make sense so far? Comprende? Comprenez-vous? Okay, so then the next one, probability of selecting red then yellow. Red then yellow. This is in order. Okay, so the first one being red will be 14 out of 34 times the yellow is still 12. Okay, the only thing that is affected when it's red will be the 13 because it's red, but the yellow is still 12. The only thing that is affected here will be the sample space. It will be short of 1. It is still dependent events. So when you do that, you get 0.150. The same way you do yellow then red, you get that. Then the one in any order, it could be red then yellow or yellow then red. Okay, so you just add the two probabilities and it gives you 0.299. Question 19. In the city of truth or consequences, do you know that there's a city like that in New Mexico? I would love to go that. I just use it, in my lessons. I like the name. Truth or consequences. Speak the truth or face the consequences. In the city of truth or consequences, New Mexico, the probability that a randomly selected person aged 30 years or older is an athlete is 21.8%. Okay, please don't be scared of all these English they write. 30 years or older. They just put it there. That 30 years is to confuse you. Okay, just look at the probability. But you need to read the question, okay? In case if they twist it. In mathematics they twist questions. So probability of selecting a person that is 30 years or older that is an athlete is 21.8%. That's a small probability. The probability that a randomly selected person aged 30 years or older is a female, given that the person is an athlete, is 20.3%. A. What is the probability that a randomly selected person aged 30 years or older is a female and an athlete? B. Would it be unusual to randomly select a person age 30 years or older, who is a female and an athlete. So B is just look at the probability you got in A and decide whether it will be unusual or not. We talked about this unusual in Module 5 homework study guide. And but first of all, let's do the A part. The A, of course, you use this. This is what, in this case, this is what they are looking for. Probability that the person is a female and an athlete. That is what they are looking for. So this is just literal equations. You multiply this times this. That's it. And with a situation like this, yes, it will be unusual because we talked about in some situations, depending on the kind of event or situation, if it is less than 0.05, which is 5%, if the probability is less than 5%, yes, it is unusual. Okay. So this is just you cross multiply because you're solving for this. They gave you this and they gave you this. They just told you to find this probability that the randomly selected person is a female and an athlete. Comprende? Comprenez-vous? Una gotaria? Ai gotaria? That is, I just spoke Igbo language, my language. Okay. Question 20. Cecilia bought a compact disc that has 6 tracks. After listening to the CD, she decided that she liked 2 of the songs. With the random feature on her CD player, each of the 6 songs is played once in random order. You know I can sing, you know. Okay, calculate the probability that among the first 2 songs played, A, she liked both of them. Would this be unusual? B, she liked neither of them. C, she liked exactly one of them. D, redo A through C if a song can be replayed before all 6 songs are played. So, this is the same thing like we've been doing. This is dependent events without replacement. So 2 songs are selected. She likes 2 songs, which means she does not like 4 songs. So probability of the song she likes is 2 out of 6. Probability that she does not like it, S prime. I use S prime in this case, or X complement. You can either say S prime or S complement. Probability that she does not like it will be 6 minus 2, which is 4 over 6. Okay, which is 2 out of 3. So probability of selecting the 2 songs that she likes, both of them, this is without replacement. Okay, the first one is 2 over 6. Okay, you didn't replace it, so you only have 1 remaining out of 5. And when you do the computation, you have 0.067. Then the second one, she liked neither of them. You still do the same thing. 4 out of 6. She does not like 4 out of 6 times 3 out of 5. Okay? And when you do the computation, you have this. Then, in the third one, as usual, we can do it 2 methods. What's the probability that she liked exactly one of them? Okay, I can do it my way or textbook way. But I will start with my way first. So with my way, that means what? She could like the first one and does not like the second one. Or. See? So you're combining both the multiplication rule and the addition rule. Or she may not like the first one and then she likes the second one. Okay? That is exactly one of them. This is not at least. Are you listening now? You see the difference between exactly and at least. If it was at least 1, that means it could be 1 or the 2. Okay? But now exactly one of them means she could like one and does not like one, or she does not like one and like the other. But if it was that at least, if they said at least she liked at least one of them, that means she could like first, does not like second, or she does not like first and likes second, or she likes both of them. Okay, if they say she liked at least one of them. So take note of that. At least, at most, and exactly. At least 5 means greater than or equal to 5. At most 5 means less than or equal to 5. Exactly 5 means equal to 5, just 5. So she likes exactly one of them means she either liked the first one and does not like the second one, or she does not like the first one and she liked the second one. So, and you do that, and this is still dependent events. So the probability that she likes the first one and does not like the second one, she likes 2, so 2 out of 6 times. She doesn't like 4, so 4 out of 5, because it's still 4, but it's now short of 1 because this is dependent events. Or is the plus. Okay, I'm taking time to explain this because this is where students have difficulty understanding it. That is why I'm taking time to explain it. So, or she does not like the first one, which is 4 out of 6, times this is dependent event. You're short of 1, okay, but there are still 2. Okay, she likes the second one, so it will be 2 out of 5. So you do the calculation and you have this. Or you can use the method in your textbook. And what is the method in your textbook? You can use this formula: probability that she likes both songs plus probability that she likes neither song plus probability that she likes exactly one song will be 1. So if we have to find probability that she likes exactly one song, that would be 1 minus probability that she likes both songs minus probability that she likes neither song. And when we do that, we'll still have a calculation here to be the same answer. The D part: if a song can be replayed before all 6 songs are played. If we do this, then we are now talking of with replacement condition, and that is independent events. Independent events. So it is still the same thing, but nothing is short of nothing. Okay, so probability that she likes both of them will be 2 out of 6 times 2 out of 6. It's not going to be 1 out of 5 anymore. No, it will be 2 out of 6 times 2 out of 6. You just read it as independent events. You're not short of anything. And this one will be 4 out of 6 times 4 out of 6. It's not going to be 4 out of 6 times 3 out of 5. No, because this is independent events. Okay, the same way, you just don't apply the without replacement condition. This is with replacement condition, which means they are independent events. And if you look at, you see, when I use my method, I got 0.444. But if you use the method in your textbook, you get 0.445. Your textbook will take both of them. Okay, your MATLAB is gonna take both of them, both answers. It will take it. Question 21. I think this is the last but not the least. The data below represents the number of driving fatalities by age for male and female drivers for a certain period. Round all answers to 3 decimal places as needed. So you see these ages. A quick look at this table tells you that 5,216 males between the ages of 16 and 20 have driving fatalities. 1,847 females between from 70 years of age and over have driving fatalities. Okay, so this is really too much, this data. We need to be careful to save lives, Don't drink and drive. If you must drink, don't drive. If you must drive, don't drink. Find the probability that a randomly selected driver fatality who was male was 55 to 69 years old B, find the probability that a randomly selected driver who was 55 to 69 years old was male. C, is a victim of a fatal accident aged 55 to 69 years old more likely to be male or female? This is all female. Okay, all female. I'm going to correct it. Let's do this. If you look at this randomly selected driver fatality who was male 55 to 69 years old. So this deals with male. And we have the event. The event is 55 to 69 years old males, which is 5,964. All over the sample space. The sample space will be the sigma, the summation. We did this summation, sigma, of all the male fatalities. Okay, so probability that the male driver was 55 to 69 years old would be cardinality of getting male drivers that are 55 to 69 years old divided by cardinality of all male drivers. So that is like sigma male drivers. So you add everything up, add up all these male drivers. Okay, and you now do 5964 divided by the summation, which is 36,153. And you round to 3 decimal places as needed. That gives you approximately 0.165. B, probability that a randomly selected driver who was 55 to 69 years old was male. So in this case, we are considering both, it could be male or it could be male over female and male. Randomly selected driver. Okay, see the difference between A and B. In A, they said randomly selected driver who was male, okay, was 55 to 69 years old. So in this case, we're kind of dealing with males here. But B, they said randomly selected driver. It could be male or female. So we are looking at, but we should be focused on, we should be restricted to only 55 to 69 years old. So this is what we are restricted to. So in this case, the cardinality of the sample space will be 5964 plus 1566. And then the probability of getting a male that is 55 to 69 years old will now be 5964 divided by the summation of these two here. Okay, you add it up and that will give you 0.792. From this, you of course the victim of a fatal accident aged 55 to 69 years old is more likely to be a male driver. This is more than 0.5. The probability is greater than 0.5. It's more likely to be a male driver. You have like 79.2% that is gonna be a male driver. So it's really, really more than the female, which should now be 20-something%. Okay, please, I think we are, these are the references and reference websites. Thank you so much for listening, folks. I hope you understood this. If you have any questions, please feel free to ask me, and watch out for other videos. And you have a great morning. And you have a great day.